Good morning, ma'am.
Good morning, ma'am.
Yesterday we completed 2 problems. Yes. So one problem is left, ma'am, that we will complete now. Then we'll discuss another topic. So see the students now. So this problem we completed yesterday. Okay, we are having 3 problems in EDTA method. So first problem we got total hardness 252 ppm and permanent hardness 168 ppm. And for second problem we got total hardness 910 ppm and permanent hardness 230 ppm. And we'll do this last problem. 3 problems I gave you in question bank. Okay, na? So everybody take this problem now. So take your notebooks. Take your notebooks, everybody. Only 46 are there. Previous class 64 are there.
మీటింగ్ ఎండ్ చేసేసరికి
మీటింగ్ ఎండ్ చేశారు మ్యామ్, అందుకోసం అందరు లెఫ్ట్
జాయిన్ అవుతున్నాం మళ్ళీ.
ఇప్పుడు జాయిన్ అవుతారా?
They'll join slowly, ma'am.
సిఆర్ ఒక మెసేజ్ పెట్టమ్మా. నరసింహారెడ్డికి.
Yes, ma'am.
Nikila, okay, send one message immediately. So everybody copy this last problem. We are completing EDTA problems now. A sample water of 20 ml required. 20 ml required. 22.5 ml of 0.02 molar EDTA solution with EBT as indicator. And 14.5 ml of 0.02 molar EDTA for the same volume of water. After removing the carbonate hardness. Calculate the total hardness, permanent hardness in terms of calcium carbonate equivalents. So in this problem also you have to find out total hardness and permanent hardness. You know the formulas. Now 52 is their number participants. 64, we are strength is 65. I don't know what others are doing sitting in the home. In participants, you are writing your name, roll number also, you keep the roll number also. Rishikesh, Sai Kumar, Tejashwini, Naveen Kumar, 77, okay. Just enough, you write roll number 96, Rishikesh, so that I can see. Now and then I will see which roll number is not joining for the class. C1 came, Sai Tejasi, C8, okay. Randomly I will check who is not joining for the class. Pavan Teja, Namita, Muhammad Kashif Ali, roll number is not there. Namita roll number is not there. Sai Madhav roll number is not there. So everybody write down my M3V3 is equal to M2V2 dash. Find out M3, students. M3 molarity of hard water M2 EDTA molarity, V3 volume of hard water, V2 dash volume of EDTA consumed. So M3 V3 is equal to M2 V2 dash. So M3 is equal to M2 V2 dash by V3. Students, on your video, Revant 81. Students, on your video, what is the problem? I want to see your face. V3 is volume of hard water. V2 dash is volume of EDTA consumed. So EDTA molarity given here.
0.02, ma'am.
Okay, ma. 0.02. Now volume of hard water, how much we have taken?
2.5.
Volume of hard water. Volume of hard water.
20.
20 ml. Now volume of EDTA consumed.
2.5.
22.5.
22.5. So how much answer will get?
0.02 into 22.5.
0.0225. Okay. 0.0225 molar that we are getting M3. So convert into ppm.
2250 ppm, ma'am.
Convert into ppm, that is M3 into 100 into 1000. So we got 0.0225 into 100 into 1000. We got the hardness, that is 2250 ppm. Okay, that is M3, total hardness. So now we have to calculate permanent hardness. Students, all everybody, you have written this in notebook.
No, I'm writing.
Yes, ma'am.
Right. These three problems are very, very important. I will send you question papers also. Okay, CIE, SCE question paper I will give you. Okay, you see that how you are getting the problems. Okay, na? I will give you CIE papers and SCE papers for you. Clear? Okay, so that you can know how to prepare problems for mid exam and final exam. Now next completed this M3 total hardness. Now permanent hardness M4V4 is equal to M2V2 double slash. M4V4 is equal to M2V2 double slash. So M4 is molarity of boiled water, you write, students. Molarity of boiled water. V4 is volume of boiled water. Volume of boiled water. M2 is molarity of EDTA. V2 double slash is volume of EDTA consumed. So what is EDTA molarity? What is EDTA molarity?
2, ma'am.
0.02. Volume of EDTA consumed. How much? Volume of EDTA consumed.
0.5, ma'am.
14.5.
14.5. Now volume of boiled water, how much we have taken?
20 ml.
20 ml. Okay. Now M4 is equal to M2V2 double slash by V4. That is 0.02 into 14.5 by 20. Okay, ma, we got 0.0145. 0.0145. Okay, M4. Okay, convert into ppm, permanent hardness. 0.0145 into 100 into 1000. We got 1450 ppm. That is the answer. Yeah. Permanent hardness. Write down, everybody. This temporary hardness, no need for you. Okay.
అవసరం లేదా మ్యామ్ టెంపరీ హార్డ్నెస్?
అవసరం లేదమ్మా, అసలు తీసేస్తాను ఆగండి పీపీటీలోంచి.
ఎందుకు మ్యామ్?
అవసరమే లేదమ్మా. ఒక్కసారి ప్రాబ్లం, జస్ట్ యూ సీ ది ప్రాబ్లం నౌ. Calculate the total hardness, permanent hardness in terms of calcium carbonate equivalent. If you get for 7 marks, for M3 I'll give 4 marks. For M4 I'll give 3 marks. Understood, everybody? You see the problem. What they're asking us to find out total hardness and permanent hardness. Clear,
Yes, ma'am.
everybody? Okay. Okay, ma, everybody complete M4 also. Molarity of boiled water and convert into ppm, permanent hardness. Students, you wrote, ma, everybody? Yes?
Writing, ma'am.
Right. So either tech talk topic or concept video, all the students, you have to give the presentation, audio and video. Okay, na? We have to see your face. Students, you are following me? Give the
Yes, ma'am.
PPT. Presentation you give neatly. Okay. At least to 10 to 15 slides you take. Okay. Don't take more matter in one slide. Understood? Okay. Like points, pictures, points, like that you take. And you
How
explain.
many slides we should prepare, ma'am?
Minimum 10 slides, ma. Minimum 10 slides.
Okay, ma'am.
But time is important. How much time?
18 to 20 minutes.
18 to 20 minutes. Time is important. Students, now we will repeat the formulas, 4 formulas. Then we will discuss another topic now. What is the first formula, ma? How to find out molarity of standard hard water? Step 1, molarity of standard hard water. Molarity formula, tell me. Students, M1 is equal to what is, tell me, molarity formula. M1 is equal to, how to find out molarity of standard hard water?
M1 is equals to V2 by V1.
Kaadu.
Given by molecular weight
into 1000 by volume.
Weight by
molecular weight.
Molecular weight into 1000 by volume in ml. So we can find out M1, molarity of standard hard water. M1 is equal to weight. If you are not, if you didn't write in your notes, now you write, everybody. M1 is equal to weight by molecular weight into 1000 by volume in ml. For example, if you are finding standard hard water calcium carbonate, we have taken 1 gram. Now write M1 is equal to, okay, or 0.1 or 1 gram, okay. So M1 is equal to 1 by 100, 1 by 100, 100 is molecular weight of calcium carbonate. 1 by 100 into 1000 by, we are preparing for 1000 ml, okay, in standard flask. So 1 by 100 into 1000 by 1000, you will get M1, molarity of standard hard water. Now tell me, students, M2, how to find out M2, molarity of EDTA, M2, formula.
M1 by V2.
M1 V1 by V2, correct. M1 V1 by V2, M1 already you know now. Okay, V1 is volume of standard hard water, V2 is volume of EDTA consumed. Now students, M3 formula.
Ma'am, M2
Students, if
V2
you
dash.
come directly to exam also, you should be able to do. Following me? Okay, so you have to remember these 4 formulas. Now tell me M3.
M2 V2 dash by V3.
M2 V2 dash by V3. M2 V2 dash by V3. Now M4 formula.
M2 V2 double dash by V4.
M2 V2 double slash by double dash
V4.
by V4. Okay, this 4 you have to remember for EDTA problems. Understood, everybody? Okay, ma? They will give you volume of EDTA. Okay, na? They will give you molarity of EDTA. Okay, they will give you how much sample of water we are taking. Yes or no? Okay, you have to find out total hardness, permanent hardness. Total hardness is? Total hardness formula. Total hardness is M3V3 is equal to
M2V2 dash by V3.
M3V3 is equal to M2V2 dash. M3 is equal to M2V2 by V3. What is permanent hardness formula? To find out
M4
permanent
V4
hardness.
is equal
M4
V4
V4 is equal to M2 V2 double dash.
Double dash.
Understood, ma? Everybody? If they didn't give you molarity of EDTA, okay, na? Then you have to find, use the formula M2 is equal to M1 V1 by V2. Clear? So then they will give you the standard hard water weight. They will give you how much weight. For example, 2 grams they have given you. Okay, 2 grams in 100 ml. Following, ma? 2 grams of calcium carbonate. 2 grams of calcium carbonate we are taking in 100 ml of water. 100 ml of water. Find out M1. How you will find out? 2 grams of calcium carbonate in 100 ml. Find out M1. M1 is equal to 2 by
100.
2 by 100 into
1000 by volume.
100. Volume in ml. Volume in ml we have taken only 100. Okay, ma? So 2 by 100 into 1000 by 100, or 1000 by, we'll take 500. For example, 500 ml. Or we are taking for 1000 ml. So volume in ml changes. In problem, if they give for 100 ml, you take 100. If they give for 500 ml, you write 500. If they give you for 1000 ml, you write 1000. You will find out M1. Understood, ma? Then they will give you to find out molarity of EDTA. Volume of standard hard water they will give you. For example, 100 ml of standard hard water. They will give you volume of EDTA consumed. You can find out M2, no? Yes or no? Okay, here we discussed only 2 steps, ma. You can do problem for 4 steps also. Okay, if they give you problem in that way also, you should be able to do. So all the students, you have to remember M1 formula, M2 formula, M3 formula, M4 formula. Clear, everybody? Students, clear? Now note down in your notebook. I'll give one problem for homework. Now take the problem now.
Ma'am,
Prepare the standard hard water. Prepare the standard hard water. Prepare the standard hard water by using 2 grams of calcium carbonate. Tomorrow you have to tell me the answer. 2 grams. Take the problem, homework problem. I will send this PPT. Yesterday's also I will send. Prepare the standard hard water. Prepare the standard hard water by taking 2 grams of calcium carbonate. 2 grams of calcium carbonate. 2 grams of calcium carbonate in standard flask. In standard flask. In standard flask. And make up the solution. And make up the solution up to 1000 ml. And make up the solution for 1000 ml. Prepare the standard hard water by taking 2 grams of calcium carbonate in a standard flask. In a standard flask. And make up the solution for 1000 ml using distilled water. Using distilled water. Using distilled water. Now here you write standard hard water. Standard, next one. Continue the problem. Standard hard water. Standard hard water of 20 ml required. Of 20 ml required. Standard hard water of 20 ml required. 20 ml required. 21.5 ml of EDTA. Volume of standard hard water, that is 20 ml we are taking. 20 ml required 21.5 ml of EDTA. 21.5 ml of EDTA. Next line. Next line. I am not giving here EDTA molarity, students. You have to find out. Okay, na? Now next line. A sample of water of 20 ml required. 20 ml required. 20 ml required. 10.5 ml of EDTA. 10.5 ml of EDTA. A sample of water required 10.5 ml of EDTA. First one is standard hard water of 20 ml required 21.5 ml of EDTA. Next line is sample of water of 20 ml required 10.5 ml of EDTA. Next line, last line. 5.5 ml of EDTA. 5.5 ml of EDTA for the same volume of water. 5.5 ml of EDTA required. 5.5 ml of EDTA required for the same volume of water after removing carbonate hardness. 5.5 ml of EDTA required for the same volume of water after removing carbonate hardness. After removing carbonate hardness. After removing carbonate hardness. Okay, na? Now calculate the total hardness. Calculate the total hardness, permanent hardness, and temporary hardness. In terms of calcium carbonate equivalents. Calculate the total hardness, permanent hardness, and temporary hardness in terms of calcium carbonate equivalents. Students, you have to do 4 steps here in this problem. You know the formulas also, M1, M2, M3, M4. Tomorrow you will tell me the answers?
Yes, ma'am. Ma'am, once read complete question, ma'am.
Now listen. Prepare the standard hard water by taking 2 grams of calcium carbonate. 2 grams of calcium carbonate in standard flask. In standard flask. ఏంటమ్మా ఎవరో టైప్ చేశాడు మ్యామ్ క్వశ్చన్ మళ్ళీ స్టార్టింగ్ నుంచి రిపీట్ చేస్తున్నా ఐఎమ్ రిపీటింగ్ అమ్మా క్వశ్చన్ ఓకేనా ప్రిపేర్ ద స్టాండర్డ్ హార్డ్ వాటర్ బై టేకింగ్ 2 grams of calcium carbonate 2 grams of calcium carbonate okay in a standard flask and make up the solution for 1000 ml using distilled water. For 1000 ml using distilled water. Next line. A standard hard water of 20 ml required. Standard hard water of 20 ml required. 21.5 ml of EDTA. 21.5 ml of EDTA. I didn't give you with EBT as indicator, no problem. Okay, na? EDTA. Next line is sample of water of 20 ml required. First standard water I gave. Next sample of water. Sample of water of 20 ml required. 10.5 ml of EDTA. Now last line. 5.5 ml of EDTA required for the same volume of water. Means same volume means 20 ml only here also. Same volume of water after removing carbonate hardness. So 3 I gave volume of EDTA. First is 21.5. Second is 10.5. Third is 5.5. So 3 you have to find out. Total hardness, permanent hardness, temporary hardness. Clear, ma? 4 formulas you write in notebook first. M1 formula, M2 formula, M3 formula, M4 formula you write. So if you get this type of problem in final exam, SCE exam, if you get also, you can do. Okay. So this problem what I gave, evening I will send you in WhatsApp. Okay, na? If you are not understanding also, you can see. Okay, and students, Okay. Okay. Now we'll stop the problems and we'll go to the next topic. Everybody understood my problem, sir? Okay. Formulas you remember. Then you can do the problem. Okay, students, in your notebook, you write the next topic. What we are going to discuss is, write down now. Treatment of boiler feed water. Write down. Treatment of boiler feed water. Treatment of boiler feed water. External treatment. Ion exchange process. Treatment of boiler feed water. External treatment. Ion exchange process. So now we are going to discuss ion exchange process. So everyone wrote? So what we are going to discuss?
Ion exchange process.
Ion exchange process. So first we have to know what is softening of water. You know what is hardness of water? What is hardness of water? How do you know that water is containing hardness? What is hardness of water? It is the characteristics of water.
Which
How do you
prevents
know
the
water is?
lathering of soap.
It prevents lathering with the soap. It prevents lathering with soap. That is known as hardness of water. Okay. Okay, ma. Now here we have to understand what is softening of water. So softening of water means, so the process whereby we remove the, completely we remove the or reduce the hardness of water. Okay, we remove or reduce the hardness of water. Okay, either means we can remove temporary hardness or permanent hardness. Okay, so that is known as softening of water. So softening of water means the process to remove the hard salts present in water. The process, okay, which we follow to remove the hard salts present in water. Now tell me 6 salts, what we discussed. What are the 6 hard salts? Calcium bicarbonate.
Magnesium bicarbonate.
Magnesium bicarbonate.
Calcium chloride.
Calcium chloride.
Magnesium chloride.
Magnesium chloride.
Calcium sulfate.
Calcium sulfate. Magnesium sulfate. So in these, what are temporary salts? What are permanent salts? Tell me.
Calcium carbonate, magnesium carbonate, temporary salts. Rest are permanent salts.
Permanent salts. So here we follow the process to remove the hard salts present in water. Hard salts present in water means we want to remove all the calcium and magnesium salts present in water, so that we will get the soft water. So that process is known as softening of water. What is softening of water, ma? The process to remove the
Hardness of water.
The process to remove the or reduce the hardness of water is known as softening of water, or we can tell the process to remove the hard salts present in water. So that is known as softening of water. Okay. So it is compulsory we have to go for treatment of water, either external treatment or internal treatment. It is compulsory because we cannot use hard water either for domestic purpose or industrial purpose. Yes or no? Okay. So especially here, I have given here, see, we are using water in boilers for steam generation. So that steam we use here to produce electricity, for the generation of electricity. So in boilers, we have to use only soft water. Okay, we have to use only soft water. Otherwise, we get the problems in boilers. We get the problems in boilers like boiler corrosion. The boiler is made up of iron. So we get corrosion in boiler corrosion, one problem. Okay, otherwise by the presence of these hard salts, we get the precipitation in boiler. Okay, so we get like the precipitate will be very hard. So that is sticking to the walls of the boiler. So that is also problem, because when this precipitate, hard precipitate is it is sticking to the walls of the boiler. So we need more fuel. Okay, we have to supply more fuel to boil the water. Okay, to boil the water for steam production. So some problems will be arising when we use the hard water in boilers. So we have to use only soft water in boilers. Okay, so we are going for treatment methods here. Treatment of boiler feed water. So the treatment of water includes here the removal of hardness causing salts. Either by precipitation or by complex formation. Means when we are adding chemicals in water, when we are using chemicals in water, we will get a precipitation. We'll get a precipitate and we will filter that water. Okay, a filtered water we will use. Or by complex formation. For example, we used EDTA. EDTA we used in hard water. Okay, ma. So what complex is formed, ma, when we used EDTA? We completed topic EDTA method. What complex is formed, ma, when we used EDTA?
Colorless stable
complex, calcium EDTA complex and magnesium EDTA complex. So it is not harmful. That water we can use. Okay. So here the treatment of water includes the removal of hardness causing salts. Okay, we are removing hardness causing salts either by precipitation method or by complex formation. So in two ways it is possible, ma, where we convert the hard water into soft water. So there are two types of treatments, external treatment and internal treatment. Two types of treatment methods, external treatment, internal treatment. So internal treatment means, I will tell first about internal treatment. So internal treatment means we are adding chemicals directly in boilers. Boiler feed water. So after taking water in the boilers, we will add chemicals so that we can remove the hard salt present in the water. Okay, so internal treatment is, it is like we are going for conditioning of water in the boiler. So itself by addition of chemicals, we will add chemicals. Okay, we will add chemicals directly in boiler feed water. Okay, so why we have to add chemicals in boiler feed water? Why we have to go for internal treatment means, sometimes, see, everybody can't go for taking a pure water, okay, containing 0 ppm hardness. So some industries, they will use the water, for example, they will use the water, soft water containing like sodium. Sodium will be present in the water. For example, lime soda process. So we use sodium carbonate chemical in hard water, so that we can remove the calcium. Present in water, but sodium will be there in water only. Okay, so you see, we discussed in types of hardness. That is calcium chloride plus Na2CO3. Calcium chloride plus Na2CO3 gives rise to CaCO3 plus NaCl. Gurtunda andarki? You can remember. Permanent hardness, I gave two examples. Permanent hardness. One is ion exchange process, I gave example. One is sodium carbonate, I gave example. CaCl2, calcium chloride plus Na2CO3 gives rise to what we get when we add sodium carbonate in water containing calcium chloride. We get calcium carbonate, that is precipitate, plus NaCl. Clear, everybody? So that precipitate we will filter, and water is containing sodium chloride now. If you use that water in boiler, What is there in water now? Sodium chloride is there, no? Due to the presence of that sodium chloride, we get boiler corrosion. Understood, ma? So to remove that sodium chloride, we will add chemicals. We will add chemicals. Students understood? Okay. But we are not discussing internal treatment methods, ma, because we don't have this topic. Just I told you what is internal treatment method. That is, we are using chemicals in boiler water directly to remove the hard salt present in water. So here there are some examples are there, ma. Colloidal conditioning, phosphate conditioning, Calgon conditioning, and carbonate conditioning. You studied about Calgon conditioning, ma, in intermediate? Calgon? You didn't hear? Calgon. Okay.
No, ma'am.
You didn't hear? Sodium hexametaphosphate. Okay. Okay. No need to worry. Okay. Now we are not discussing this topic. Now external treatment means before using water in the boiler, we will do, this is like outside process. Okay. We will treat the water outside only. So we'll convert hard water into soft water. So that soft water we will use in the boilers. Okay. So the treatment given to water for the removal of hardness causing salts before it is taken into boiler. Before it is taken into boiler. So that is known as external treatment of water. This is outside process. So you have to remove the hard salts present in water. Then you can use that water in the boilers. So there are some examples are there. Lime soda process, zeolite process, ion exchange process. Okay. So we'll discuss only one method, ion exchange process. So students, tell me what is external treatment? What is external treatment?
Removal of hardness causing salt before it's taken.
Removal of hardness causing salt.
Removal of hardness causing salts before it is taken into the boiler. Before it is this is like outside process, my external outside process. We will remove hard salts present in water. Then we can take that soft water into the boiler. That is external treatment. What is internal treatment? Students, what is internal treatment? What is internal treatment? You know external treatment now. What is internal treatment? What we will do in internal treatment?
Conditioning of
We'll
water
add
body.
chemicals directly to the boiler.
We will add chemicals like, for example, sodium carbonate, sodium phosphate. So we will add chemicals directly into boiler water. Okay, boiler water, so that we can remove the hard salts present in water. So next, we are going to discuss this topic, ion exchange process. In external treatment, we are discussing only one topic, ion exchange process. So what is mean by ion exchange? Now tell me the students, what are the cations present in hard water? Two cations. Cations present in hard water.
Calcium and magnesium.
Calcium and magnesium. What are the anions present in hard water?
Chlorides and sulfates.
Chlorides and sulfates. Okay, na? So remember this 2 to enough. Cations are calcium and Ca2 plus and Mg2 plus. Anions are chlorides and sulfates. So what is ion exchange means? Ion exchange is a process by which ions held on a porous, especially insoluble solid. Insoluble solid means we will take polymers. Ion exchangers, we will take polymers here. Okay. So insoluble solids are exchanged for ions in solution, ions in water. Okay, ions in water that is brought in contact with it. So we are taking here polymers. Polymers are containing the ions. What ions polymers are containing means functional groups. We can take H plus ions and OH minus ions. H plus ions and OH minus ions. So that we are taking in polymers. So now I will tell you what is ion exchange resin. You will understand very clearly. Ion exchange resin. Ion exchange resins are insoluble, cross-linked, high molecular weight organic polymers. So we are taking high molecular weight organic polymers. These are porous structure. Pores will be there in the structure with a porous structure and functional groups attached to the polymer chains. And the functional groups attached to the polymer chains. What are the functional groups means? We'll take H plus ions and OH minus ions. So these are responsible for the ion exchange properties. These are responsible for the ion exchange properties. In next slide, you can see clearly now. There are two types of ion exchange resins. One is cation exchange resin. One is anion exchange resin. Two resins we required. To remove cations present in water, we use cation exchange resin. To remove anions present in water, we use anion exchange resin. Following me, students? Ion exchange resins are two types. We will use cation exchange resin and anion exchange resin. So what is cation exchange resin means? Cation exchange resin is styrene, divinyl, benzene copolymers. Styrene, divinyl, benzene copolymers. See here. These are cross-linked structure. Styrene, divinyl, benzene copolymers containing the functional group sulfonate group. Looking at the structure, everybody? Yes, ma? So cation exchange resins are styrene, divinyl, benzene copolymers containing the functional group either carboxyl group or sulfonate group. Look at the structure here. This is cross-linked high molecular weight polymer. Okay, what is that we are taking is styrene, divinyl, benzene copolymers with a functional group COOH, or we can take sulfonate group. Okay, the cation exchangers are represented by general formula R. We can't write a structure, no? So we are just writing R, and here functional group H, RH. Okay, so the cation exchangers are represented by general formula RH. Okay, so these cation exchangers are capable of exchanging their H plus ions with cations of the dissolved salts. With cations of the dissolved salts present in water. Present in water means this H plus ions are exchanged with the Ca2 plus ions. Exchanged with the Ca2 plus ions present in water. We will discuss the process, you will understand. Okay. So R is the general structure of resin. H is the exchangeable with cation present in water. Exchangeable with cation present in water. So next is anion exchange resin. Tomorrow we'll discuss this one. Okay. So this is the diagram for ion exchange process. We will pass the hard water or cation exchanger bed, so that here exchanging of the cation like a Ca2 plus with H plus is taking place. We will get R2Ca plus H2SO4. R2Ca plus H2SO4. So don't worry, this we will discuss tomorrow slowly. After discussing anion exchange resin, then I will discuss the process, okay, with the diagram. Clear now? Clear, ma? So tomorrow you have to listen this class, okay? So today just I told you what is ion exchange resin. Students understood, ma? Class?
Yes, ma'am.
You know what is internal treatment, what is external treatment. In external treatment, we are going to discuss one topic, ion exchange process. Okay. Shall I end the class?
Yes, ma'am.
Tomorrow
Send
after...
this PPT, ma'am.
Yes, I will send you. From 3 days, I have to send 3 PPTs. Monday, Tuesday, Wednesday. Today, Thursday. Okay, I will send. You. Okay.
Yes, ma'am. Send all.
So this topic tomorrow you listen, then you will understand, ma. Okay, na? Tomorrow we'll discuss. Okay. ఏంటి పవర్ పోయిందా?